Hello, everyone. My name is Veronica Cancio. I'm the Land Use Citizen Science Project Coordinator, and today we're going to be talking about our project's findings to date. Our Land Use Citizen Science Project encompasses two initiatives. We have our Living Shorelines Initiative, which is a water-based restoration effort, and a Buffer Shorelines Initiative, which is a land-based restoration effort. And when we first started this project, we really wanted to conduct shoreline surveys along the Indian River Lagoon or adjacent waterways as a way to determine areas or shorelines that could really benefit from our restoration efforts. Since then, we've conducted shoreline surveys for Indian River County, Brevard County, Martin County, and St. Lucie County. And as you can see here for Martin County, most of their shoreline is comprised of bulkhead, or otherwise known as a seawall. And this is just a great example of a shoreline that could really benefit from our buffer shorelines initiative. And when we look at St. Lucie County, it's mainly comprised of a natural shoreline, which is what you want to see. So once again, this is just a great tool for us to focus our efforts on those areas that could greatly benefit from either our living shorelines or a buffer shorelines initiative. And we're going to be talking about the living shorelines first. For those of you who are not familiar with the living shorelines, there are natural structures placed in the water with the primary focus of helping with erosion or restoring our shorelines, but it also has great secondary benefits like purifying our waters, buffering floods, storing carbon, and attracting wildlife. And in 2019, with the help of our citizen scientists, we've installed 9 living shorelines on Indian River Land Trust properties. And we're very excited to be installing another living shoreline in 2024 in Riverside Park here in Vero Beach. As a part of this project, with the help of our citizen scientists as well, we conduct pre and post monitoring. And when these sites are initially installed, they're monitored seasonally for the first 2 years, so 4 times a year for 2 years. And as time passes by, they're monitored less frequently. And we mainly monitor those great secondary benefits at these sites. For example, the oyster recruitment, biodiversity around the living shoreline area, shoreline plant coverage. So we look at the shoreline and identified percent and species of plants. Percent seagrass coverage in front and behind our breakwaters. And the last one here is less of a secondary benefit and more of an additional parameter that we look at. ORCA is a science-based research organization, so we like to gather as much information as we can. So this is just an additional parameter that we look at our sites. So we're going to be talking about oyster recruitment first. As some of you may know, oysters are a vital component to our environment. They're filter feeders, and they're associated with improved water quality. And since our installation of our sites, we are seeing oyster recruitment across all of our 9 sites. But 78% of our sites saw an increase in percent live oysters located in the subtidal region from September of 2021 to March of 2023, which is just amazing to see. Another thing that we look at is total abundance or biodiversity in the area. And the way that we do this is we go around the breakwaters or the structures with a seine net, and then we identify and quantify the organisms that are in that location. And what we're learning is that total abundance or biodiversity is seasonally based. And we're seeing a greater abundance during the spring and fall as opposed to the other time periods, with 5 out of our 9 sites peaking in total abundance in March of 2022, and 4 of our 9 sites peaked in total abundance in March of 2023. So overall, our structures, our living shorelines, are being used as habitat and refuge by organisms, which is what you want to see. Most excitingly, we're going to be talking about seagrass. Seagrass coverage specifically So in order to have chosen these sites, not only were they chosen because they're experiencing erosion issues, but in order to get a permit to install these living shorelines, those sites had to have less than 1% or 0% of seagrass present in that location. So these sites started with no seagrass or less than 1%. And since the installation, specifically for shoregrass, which is this grass you're seeing right here to the right, 6 out of our 9 living shoreline sites have increased in seagrass coverage from March of 2022 to March of 2023. And this just emphasizes the importance of longitudinal monitoring, because if we hadn't continued to monitor these sites, we wouldn't have been able to capture or document the seagrass presence at those locations for those first 2 years that those sites were installed. And not only were we able to capture seagrass presence, but we're seeing 2 different types of species of seagrass at our sites. We're also seeing paddlegrass. So 4 of our 9 sites have paddlegrass presence during the March of 2023 monitoring. So once again, it just emphasizes the importance of longitudinal monitoring, because without that, we wouldn't have been able to capture seagrass presence, let alone 2 different types of species. So this is the additional parameter that I was mentioning earlier. This is herbicides in our sediments. So we're looking at glyphosate and atrazine concentrations in the sediments for all of our living shoreline sites. And there's a lot of conversation right now on the effects or the potential effects herbicides in sediments have on seagrass growth and success. So we were very excited to be monitoring this along with our seagrass coverage. So what you're seeing here is the concentration of herbicides on your y-axis and living shoreline sites on your x-axis. And the blue bars is glyphosate concentration, and the green bars is atrazine concentration. So one thing that stands out is site 6 had the only measurable concentrations of atrazine in front of the structure, and it also had relatively high glyphosate concentrations. And when we compare that to our seagrass presence, that site had less than 1% of seagrass. And although it's very interesting to compare those two, we can't really say those are correlated, especially if we look at another example like site 7, which had relatively low concentrations of glyphosate, but they're also seeing less than 2% seagrass presence. So very interesting stuff to be looking at monitoring. So we're interested in seeing what the future monitoring is going to look like and what more information comes out regarding herbicides in sediments and seagrass. That we're very excited to be installing a new living shoreline riverside park in Vero Beach. We're going to be using these breakwater constructions in the water, and we're partnering with FOS in the installation of the seagrass planting and monitoring. And we are looking for a team of citizen scientists that are interested in taking part in the quarterly monitoring of these sites. So if you are interested in participating in the monitoring, please reach out to me and I'll give you more information on how to get involved. So now we're going to be talking about our buffer shorelines initiative. We currently have over 70 citizen scientists taking part in this project. We have installed 9 sites, and we've transformed over 10,000 feet from just regular turf grass to native vegetation or buffered shorelines. And we conduct pre and post monitoring for these sites. And as our post monitoring, we conducted 1 month, 3 months, 6 months, and 12 months after the installation. And we currently have a site in counties from Brevard County all the way down to Martin County. We have at least 1 buffer site in each of those counties. So one of the major problems our lagoon is facing is pollution entering our waterways from stormwater runoff, especially from properties that look like this. So this is what your typical Florida property looks like. You have your green lawn up to your seawall next to a waterway. And when you have those heavy rain events or irrigation, anything that's on these yards, whether that's fertilizer, pesticides, or pet waste, that water is taking all of those pollutants and introducing them into our waterways, thus decreasing our water quality. And although it's a problem that we're facing, there is a solution to this. By simply adding a buffered shoreline in between that turf grass and that waterway, not only are we adding a physical barrier to things like grass clippings and trash, but also a chemical barrier to those pollutants like nutrients and those chemicals that might be harming our water quality. And not only do they provide a physical and chemical barrier, but they also have great secondary benefits by increasing the biodiversity in the area because we're using these native plants that are attracting native birds and insect and pollinators. So it's just a really great solution, an easy low-hanging fruit solution to a problem that we're facing. So I want to walk you guys through a case study and what it's like to really install one of these buffer shorelines and monitor these. So what you're looking here is at a site in Faber Cove in Fort Pierce that we conducted a buffered shoreline or installed a buffer shoreline. So initially we would go to the site and do a site visit, site analysis, and we would determine if this site is suitable or could benefit from a buffer shoreline. So this site could definitely benefit from a buffer shoreline. So the first thing that we do is we go out and deploy our collection devices along the seawall, and we wait for 2 separate rain events, and we collect that runoff that would otherwise be leading into our water. We take it back to our lab with the help of our citizen scientists, and we test for those nutrients, phosphate, ammonia, nitrate, and nitrite. And once we've conducted our pre-monitoring, we can go ahead and move with the installation, again, with the help of our citizen scientist. And here we work with the homeowners to make sure they're happy with the plant selections and the design, because the more the homeowners are invested and happy with their backyard, the more likely they're going to take care of it and maintain it. So once we have the design, the plant selections, we go ahead with the installation with the help of our citizen scientist. And then we conduct our post-monitoring 1 month, 3 months, 6 months, and 12 months after the installation. So what you're seeing here is just 1 month after the installation. So we go out once again, deploy our collection devices along the seawall. We wait for those 2 separate rain events. We collect the water, bring it back to our lab, and we test for those nutrients. And this is what that site looked like just 3 months after the installation. As you can see, the plants are growing, they're flowering, the roots are more established. So overall, it just looked beautiful. We deploy our collection devices again along the seawall. We wait for those 2 separate rain events, collect the runoff, bring it back to our labs, and test for those nutrients once again. Once we have the pre and post monitoring, we can look at the data to see if there's been any change. So what you're seeing here is that data for that specific site in Faber Cove. On your y-axis, you have your concentration. On your x-axis, you have your nutrients. And the blue bar is your pre-monitoring, so the data that we collected before we did anything to the site. And your red bar is your post-monitoring for 1 month and 3 months, specifically for this site. So as you can see, phosphate had a reduction in concentrations before and after the installation. Ammonia, nitrate, and nitrite tend to vary throughout all of our sites, but phosphate, we're seeing a reduction in phosphate not only 1 month and 3 months for our sites, we're also seeing it 6 months after the installation. So this is a site that we transformed in Wabasso. So what you're seeing here, the data is pre versus post for phosphate concentration 6 months after the installation. And as you can see, we're still seeing that reduction in phosphate. And not just at 6 months post, we're also seeing it a year after the installation. So this is a site in Shepherd's Park in Martin County that we transformed. It's a public park. And this has a year's worth of data. So what you're seeing here is the baseline phosphate concentration versus the post phosphate concentration 1 year after the installation for different drains that were located in this location. And as you can see, each drain had a reduction in phosphate. So it's really, really exciting things that we're finding with these buffered shorelines. And not only are we seeing that reduction throughout time as these buffers keep establishing and growing, but we're also seeing it throughout different types of properties. So what you're seeing here is our most recent sites that we've transformed. So we have 3 Martin County sites, and this bottom right here is a site in City of Satellite Beach, a public park that we transformed. So again, super exciting that not only are we seeing that reduction in phosphate throughout time, we're seeing it in business properties like River Palm Cottages, in HOA condominium complexes like Palm Cove and Yacht Club, private properties like Store and Yacht Country Club. So once again, it's super exciting things that we're finding, and any property can be a part in installing a buffer shoreline and being a part of the solution. And super exciting news, our data is driving change because of our buffer shoreline initiative and our data coming out of this project. The city of Vero Beach established an ordinance where any new property located adjacent to critical waterways has to establish an upland buffer zone with a minimum width of 10 feet. So this is amazing. This is what we want to see. This is what we want our data to be used for. So once again, really exciting news that the city of Vero Beach established this ordinance because of the data that's coming out of this project, thanks to our citizen scientists and all the staff members here at ORCA. So once again, not only did I want to show you guys that reduction in phosphate in our data, but I just wanted to show you how beautiful these buffer sites look and how important it also is that it attracts those pollinators and native birds and insects. So that secondary benefit of biodiversity is also very important. So what you're seeing here is a private property in Stewart Yacht and Country Club. And as you can see, it just looks beautiful, flower, many colors. This is the condominium complex that I mentioned earlier. So this was a really long stretch around this creek right here. This was that business property that I mentioned earlier as well. This is River Palm Cottages. So they knew about ORCA. They wanted to take part in this project. So they reached out and we were able to transform a little bit of their section into a buffered shoreline. And this is Twitchell Park in Stewart. And this actually has a really cool backstory. This land right here was purchased by these 6 different homeowners as a way to prevent it from being developed and restoring it. And they wanted to improve their shorelines. So we were able to work with them along this 250 linear foot section and transforming it into a buffered shoreline. And this is the before and after picture, and I just think it looks way better than before. And not only does it look beautiful, but again, it's helping reduce the pollution in this area. And this is the DeSoto Park in City of Satellite Beach that we transformed. This was a 300 linear foot section. It's a public park that we transformed for a more natural looking buffered shoreline. But there's also a dock in this area that we transformed this small section as a way to implement a demonstration site. So there's different substrates in that location, different vegetation, and there's also educational signs at this site to help homeowners or anybody who's interested in transforming their backyard into a buffered shoreline. They could go to this site and look at the demonstration and look at the different ways buffer shorelines can look, and also change the perspective on the beauty of what native plants look like. So we partner with the City of Satellite Beach to do that. And they also have this cool Adopt a Canal program where they are giving homeowners that live near the canals a match of a $500 match. So if they want to transform their backyard, they're willing to help them do that. And they also have this site to show them, hey, this is what a buffered shoreline could look like, and this is the different substrates and plants you could use in your backyard to make it look beautiful. So really cool collaboration that we did with the city, and they're also doing really awesome stuff with the Adopt a Canal program. So if you live in Brevard County, you should definitely check that out. And if you want more information, feel free to reach out to me and I can share some of the information regarding that. So we can't do any of this without our funders, so we want to say thank you so much to Impact 100 Martin, 11th Hour Racing, and the Garden Group. And we also want to say thank you to our citizen scientists, because without them, this wouldn't be possible. So thank you so much.